Alrighty guys, so we're going to continue on, and today's lesson we're going to talk about angle bisectors. Before I get into this lesson, it's kind of a shame that we're not in person right now because this particular lesson falls in the section where we talk about constructions, where I would give you a compass and a straight edge. I would actually construct some of these things, but of course we don't have time for it, and we're not in person, and it's hard to do virtually. So we're going to focus on one piece of it, which is an angle bisector, and look at some algebra with it, okay? So let's talk about what an angle bisector is first. So an angle bisector is a ray that divides an angle into two congruent angles. Okay? The way I always like to think about it is, well, let me show you over here. So in this diagram over here that I hand drew, I drew it on the piece of paper and put a picture of it in here, but all your examples today are hand drawn, as well as all the examples on your homework. You're welcome for that, because I am OCD, and most every assignment for angle bisectors I have found, the angles aren't exact what they need to be, and so it drove me crazy, and so I thought, you know what, I'll make my own. So everything I've constructed is as close as I could get drawn in my hand. Anyway, that's just me kind of showing off. All right. So we have an angle over here. The big angle is DEG. That is the angle that is being bisected. And I've said that here. We're saying EF. Now, because I can't draw it, I need to add this in here. The ray EF is bisecting angle DEG. So this ray, starting here at E and going out towards F, that ray is cutting this big angle into two congruent pieces. And so if we wanted to draw that, or notify that, we could put a little arc there and one arc here. Okay? I don't know if I've mentioned this yet, but I'll mention it here. Just because these little arcs that I drew are different sizes doesn't mean anything. It's the number of arcs that count. Okay? I put one arc for each little piece inside that angle. That means that this angle is the exact same measure as this angle. Okay? So we're bisected, and I usually tell my kids bisect means cut in half. Like bi means two, and sect means to like section. And so we've got two sections, or we've cut it in half. All right, so let's just look at this for a minute. If the measure of angle DEF is 37 degrees, so let's look at our diagram. DEF. That is this angle right here. It's one of the pieces, and I'm going to label that just for myself. Find the other angle measures. So let's look. The measure of angle FEG. FEG, that's the other piece, and it's supposed to be the same as the DEF, so we're going to say that is 37 degrees. All right, then we want the measure of angle DEG. DEG, that is the big angle. Let me go and put this other 37 in here. All right, DEG, both halves of it are 37, so you can think about it as 37 plus 37, or 2 times 37. Either way works, and you should get that it is 74 degrees. All right, that's just a little small example of how an angle bisector works. What you're more likely going to do, and what's all on your homework, is you'll have problems like this example and the second one that I'm going to do. You'll be given an angle that has been bisected, and I will tell you that like I done here. And I will give you some measurements that are algebraic expressions. And you'll have to do one of the following. You would have to just find x, or you could find one of the angles. In which case you find x first and then go plug x back in appropriately. So All the examples I'm going to do, we're going to do everything, and then on your homework, I'll ask you a part of it. I could ask you for a piece, or the other piece, or the whole. I could do any of that. Okay, I'm doing it all on your notes just to show you how you could do it. But anyway, all right, let's do this. So I need to draw my ray symbol because I can't add it on two Google Docs. So the ray KL bisects the angle JKM. So I like to add this in for myself just to know that they're supposed to be congruent. You don't have to do that. I just do because I'm, I don't know. I'm weird, I guess. All right, so let's look and see what I gave you first, because whatever I give you here depends on how you set up the problem, okay? So the measure of angle JKL, that is a piece. I'm going to label that for myself. Actually, instead of piece, let's use this. Let's use this word. It's half. It is a piece, but it's precisely half the big angle, so I'm going to say it's half. And then the measure of angle LKM, that's the other half. Okay? So this is the first kind of problem I give you. I give you measurements for both halves. You'll set up an equation and solve it and find these angle measures. How do you set the equation up? Well, it goes back to the definition. The bisector cuts the angle into two equal pieces, essentially. I've given you both pieces. The definition says both pieces are the same, and so this half is supposed to equal this half. So we'll set them equal to each other. 4x plus 14 is going to equal 8x minus 26. Okay, variables on both sides, so I'm going to move the smaller one. So 14 equals 4x minus 26. Now we'll add 26. Let's see if I can do math in my head. 40. We'll divide 4. So x is 10. Let me double check myself. I should be more confident, but I'm not. Yeah, it's 40. All right. Now that we found x, we can find these other angle measures because they all have x in them. So JKL is 4x plus 14. So 4 times 10 plus 14. 54 when you simplify that. Degrees. Yeah. Yeah, 54. Okay, and then we've got 8 times 10 minus 26 for KLM. Oops, I made a mistake. This is supposed to be LKM. Oh, that's funny. Let me fix this. LKM. If you're making your own notes or printing mine off, make sure you make that correction. I made a mistake there. That's what I get for making everything homemade. I make a mistake. All right, evaluate that. That should also be 54 degrees. And then to find this angle, that's JKM. JKM. That's the whole angle, okay? And so what you could do is both halves are 54, so you could add them together. That would give you 108, which is what the angle is supposed to measure. Or what I would do And more likely what you're going to encounter on any assignment or anything later in the future is once you get one half of it, just double this. So 2 times 54, and that will get you the whole. Okay? So 2 times 54 is 108, or when you find both halves, 54 plus 54, that will get you the 108. Either way you want to do it. All right, that is one of the ways you're going to see it where you get both halves. Now let's look at the other example. Let's get this down. All right, let me add my ray sign. The ray RS is bisecting angle QRT. So we know this is our bisector. And so this piece, let me make it connect, is congruent to this piece. Half, I say. Okay, let's look at what I gave you now. The measure of angle QRT. So QRT. That's the whole angle. So I'm going to write that out. I'm going to label myself that that's the whole. SRT, that's half. So notice the difference in this problem. Instead of getting both halves, you get the whole thing, and then you know half of it. So your setup is going to be different for this kind of problem. What we need to do now is I know half of it. This half is 5x plus 1. And then because these are congruent, let me write that in here. We know this is 5x plus 1. Because this angle and this one are congruent, we can go ahead and say that that's also 5x plus 1. So we have two of these things. And they're going to equal this whole thing right here. Okay? Here's what I do. I like to write it like this. In my head, I know that if this is half of this, it's going to take two of these to make this whole thing like I've written over here. So I'm going to double the small piece, double the half, and equal it to the whole thing. Okay? And I'm going to actually solve this out because this is my preferred way to do it. The other way you could do it, and I write it up here, is you could write out the 5x plus 1 twice and just add it to itself. And then say it equal to the whole. Okay? This is an equally valid way to do it. I just don't think that way. My brain doesn't work that way. I think to double the small one. But if you want to do this way, it will work out perfectly. It will. I just don't. That's not my preferred way. All right. Let's simplify this. So first thing I need to do is distribute the 2. So 10x plus 2 equals 11x minus 4. Subtract the 10x. So 2 equals 1x minus 4. I have to add the 4. So then I get x is 6. All right, now I have to try these other angle measures. Excuse me. Now, I want to find QRS. I'm going to come back to this one in a second. Let's go down to the 2 that we were given. So SRT was 5x plus 1, so 5 times our x plus 1. You simplify that will get you 31 degrees. QRT is 11 times our x, subtract 4. That will get you 62 degrees. Notice that 31 is half of 62, so we've done our job right. We've solved it correctly. Now to find this one. Remember, we said that whatever we get for SRT, it's going to be the same for QRS. And so once I find this half, I automatically know this half. So I'll go ahead and transfer 31 up here. Okay? And that's it. Angle bisectors are really easy if you can solve equations of variables on both sides. It's not that hard. So just remember, two kinds of problems. One is where you get both halves and you set those equal to each other. The other problem is you get the whole thing and then half of it, in which case you double the half side and set it equal to the whole. Or you can write the half part out twice and equal it to the whole. All right? That's all I have for this lesson. So make sure you watch this through entirely before you start your homework. And if you run into any issues or you need help, please let me know.